This is Parul Narang from
Good
AWA
evening.
India Association. On behalf of AWA India Association, I welcome you all to the webinar on water treatment, sustainable solutions for small and rural sites. So in the webinar today, we will be having three speakers, Mr. Abhishek Praveen Jadhav, Dr. Ayman Pasek, and Mr. Amit Kumar Christian. And we have a moderator, Ms. Garima Ghanshyamdas Mittal. I will quickly just introduce you with Ms. Garima, and then we will start with the speaker's introduction and presentation. Ms. Garima is a chartered engineer from Engineering Council UK and project management professional with more than 29 years of experience in water supply and sewerage projects. She is currently functioning as a technical director with Arcadis. She has a vast knowledge in the field from Indian and international perspective, and she's also a member of AWA India Association. And before I hand over to Garima, I want to make an important announcement here. AWA India is hosting its 4th annual international conference and exhibition AIC 25 at Indore from 8th to 10th of December 2025. There will be a pre-conference workshop on 8th of December. Call for paper abstracts will be announced very soon. For more details, please log on to our website www.awa-india.org. Now I request Ms. Garima to start with the speaker's introduction.
So good morning, good afternoon, everyone, and thank you for the warm introduction, Parul. So as Parul said, I would be moderating this session, and so I welcome you all to this webinar on sustainable solutions for rural and small sites. For this, and we all are aware that access to clean water and sanitation and sustainable infrastructure is a cornerstone of any rural development. And so today we will look at various innovative approaches, practical challenges which are there, and how we can conquer those solutions. And we have a good panel of speakers here today with us who have carried with them their technical strength, their experience, deep technical knowledge, and also they have a strong commitment to community-based solutions. So I'm sure we will get their insights will be useful and which will spark a lot of ideas, and we can take a lot of actions from them. So I welcome to all of the speakers. So I'll have this opportunity to introduce our speakers. First speaker would be Mr. Abhishek Praveen Jadhav. And Abhishek has completed his ME in Environmental Engineering from Pune University, and he is currently working as Director CEO in WS2 EPL, who are also foremost to develop and manufacture various capacity packaged water treatment plants in India. And he'll be presenting on package treatment plant, sustainable boon to individual water supply schemes. Welcome, Mr. Abhishek.
Thank you.
Next, we have Ayman Pasek. He is a PhD in polymer science from Aiken University. He has 40 years of experience in the field of wastewater treatment, developing innovative process for the treatment of complex effluents. He is inventor of Levapor MBBR IFAS carriers, and we are quite lucky to have him here today with us, and he will be presenting more on the package treatment plants, upgradation of existing activated sludge for BNR. So welcome, Mr. Ayman Pasek, to this webinar, and we are looking forward to have your insights. Lastly, we have, can you go to the next slide, please, Parul?
Yeah.
Lastly, we also have Mr. Amit Kumar Christian, who is also from Levapor.
Good evening, everyone.
He is
I am now connected. Can you hear me?
Yes.
And see you, because it was some problems with the connection. I got a message that I'm attending as a visitor, but then came the message later that I can attend as presentator.
Yes, that is
So
what.
now,
Yeah.
Yes, now is okay.
Okay, great,
My
great.
outfit finish, you know.
That's great.
and
That's
ready.
really great. That's great. That's great. Right. So, and yes, so we are looking forward to your presentation. And lastly, we have also Amit Kumar Kristen with us. He is also with Liverpool. He is an MSc in Environmental Science from Middlesex University, London, UK. And he also has like more than 20 years of vast experience working in the field of water, wastewater treatment. And he also has a strong interest in biological wastewater treatment process management, and he's currently working as Director, Liverpool India Private Limited. And he also is going to co-present on the package treatment plant upgradation of existing activated sludge for BNR. So with this introduction of our speakers, now I would request Mr. Abhishek to get started with his presentation. So,
Sure.
so
My screen is can be seen.
yes, we can.
Yeah. Thank you. So good evening all and good afternoon all. It's absolute pleasure to be a part of this webinar among such experts across the globe. And ensuring access to safe and reliable drinking water continues to be a significant challenge in many rural and underserved regions. So my topic today, Packaged Water Treatment Plant, a boon to water supply scheme, aims to highlight sustainable and scalable solutions that can be effectively address these issues which are faced in rural areas of India. It offers a compact, modular, and efficient alternative solution to unconventional treatment setups. It allows enabling quicker deployment, reducing civil infrastructure, and consistent water supply. So going back a little brief history of water treatment plants across Maharashtra, packaged water treatment plants are nothing but the parenthood comes from the unconventional treatment plants. So in 1970s, mostly one large capacity conventional plants were constructed in large cities, and there were no capacity plants in rural areas because of they were treated with partial treatment, because scaling down the conventional treatment plants, the conventional technologies were not suitable for small plants because the cost went high. Dependence on mechanical equipment, rotary parts, and electricity made them inappropriate for the rural conditions. So the government of Maharashtra then led a large research program from 1970 to 1980 to find appropriate solution for rural water treatment. As a result, unconventional plants were developed, which were cheaper to construct and simple for operation and maintenance. The earlier constructed plants consisted of weir mixer, gravel bed flocculation, tube settling tank, and dual media filters. The development of unconventional plants carried on from 2000. From year 1970 to 2000, lots of plants were constructed, unconventional treatment plants were constructed. And government took a review of all these plants, and it was found that the unconventional treatment plants are sustaining in rural conditions and are still in very good progress. So the mass implementation of standardization of plants in state of Maharashtra started from capacity of 0.5 mld up to 5 mld. The unit processes include weir mixer, mechanical flocculator, tube settling tank, and rapid sun gravity filters. This was specially for village group, small cities, taluka places, and the raw water source was surface water, rivers, dams, lakes, and canals. So why was there still a need for prefabricated package treatment plants? In year 2000, Government of India declared ambitious program, that was Jal Jeevan Mission, to provide safe drinking water to all the population by year 2024, which is now extended up to 2027. Now, to complete all these projects, the speed and correct execution of small plants was not possible with concrete tanks in remote places and in time-bound period. Lack of skilled labor was an issue. Engineers, contractors were the main cause, creating possible delays in execution due to the labor issues, material availability, time-bound projects, which got into development of prefabricated treatment plants. Now, even before the Jal Jeevan Mission was declared, Maharashtra Jeevan Pradhikaran, the government body, MJP, had already started developing the prefabricated plants, because MJP had realized that for speedy and correct execution of small plants for mass application of water supply schemes in time-bound period, package plants were a prerequisite solution. Now in year 2018 and 20, unit processes were rationalized from point of that it should be robust for operation. It should come with minimum maintenance in any rural condition. The detailed specifications were prepared and put into the DSR, that is, the plant capacities were standardized. Guidance to engineers, contractors, operators was provided through the documents on basis of concept of new technologies. So earlier, initial efforts for site fabrication were encouraging, but not satisfying, as the desired quality which was required was not achieved on site fabrication. And tackling corrosion in mild steel was also a big issue. So hence it was decided to encourage shop, not fabricated, but manufactured, standardized and transportable plants. So now these plants are manufactured in an MIDC area, industrial area, stacked into a container, stacked into a flatbed trailers and taken anywhere across the country. So looking at the shop manufactured packaged water treatment plants, what are the units? It consists of a cascade aerator, receiving chamber, coagulation tanks, mixing cum measuring weir, mechanical flocculation tanks, tube settling tanks, rapid sun gravity filters, and chlorination. The only required civil structure here is a pure water sump or a pump house. Looking at the comparison of a prefabricated water treatment plant and a conventional water treatment plant, we can see on the left how packaged treatment plant looks compact and takes less space. This plant takes like 3 months to install the scheme, and it can be commissioned in 6 months, while unconventional treatment plants take anywhere about 12 to 18 months to construct and takes 24 months to commission, which takes a big difference, and hence the prefabricated packaged WTPs are still very positive and beneficial in rural areas. Looking at the schematics of prefabricated packaged water treatment plants, first is the cascade aerator, which is used to oxidize iron and reduce dissolved gases, which is the first inlet of raw water source. Further, the water is taken into the steeling chamber. Steeling chamber dampens the water and which the silt which comes with it. So the silt gets collected at the bottom, and it passes over the weir, measuring weir notch. It has a V notch attached to it, which is also beneficial to measure the flow, and according to which the dosages can be set. Further, it is taken into the mechanical flocculator, which agglomerates the coagulated particles into settleable floc, which has a detention period of 10 to 20 minutes. And this agitator has a revolution speed of 4 to 6 RPM. Now this water from downwards is taken up into the tube settlers from the floc distributor pipes in the upward direction, which are installed with tube settlers in the center. So these tube settlers are in 60-degree inclination. So the treated water gets taken up into the collection trough, and the settleable floc gets the surface of the tubes and is taken down in the hopper bottom and can be drained. Further polishing of the turbidity is taken into the rapid sun gravity filters. The tube settlers back has a detention period of 20 to 30 minutes. That is as usual as the unconventional treatment plant. And the rapid sun filters, further polishing of the turbidity is done. And it has a freeboard of like 0.25 meters at top. Further, and it can be taken into the pure water sump in the civil structure, and it can be distributed further with the pumps or by gravity into the ESR storage, elevated storage reservoirs, and to the village. As I've already explained this process, the only mechanical rotating equipment here is the mechanical flocculator, Thus, the required maintenance is minimized into the whole packaged water treatment plant. So this is how a 1.5 MLD capacity plant looks like. We can see at the top one number, that is alum dosing tanks, which are made in fiber reinforced polymer FRP dosing tanks. Further, the cascade aerator the water is taken into the stilling chamber, mixing cum measuring weir, to the flocculator next, mechanical flocculator. Then fifth is the tube settling unit with the galvanized iron trough at the top, which avoids the rusting of the mild steel due to the water. And next is the sixth, that is the rapid sun gravity filters with a supporting gravel of 50 to 2 mm gradient and filter media of 0.55 to 0.65 mm. And then that is the seventh is the pure water sump and overhead pump house. It has an arrangement of gas chlorination at the back and the drain disposal at the bottom. After the backwashing, the backwashed water is further taken into the wash water recirculation system and is recycled back into the WTP. Now this is a prefabricated packaged WTP of capacity 3 MLD. So this is nothing but two streams of 1.5 MLD each. The same with the stilling chamber at the center, the mechanical flocculator, tube settlers, and rapid sun filters. So two streams of 1.5 MLD are attached and made into 3 MLD capacity plants. These are few photographs of water treatment plant, standardized photographs, that is how a 0.5 MLD capacity plant looks, how compact around for the scheme, with the ESR and pump house beside it. 1 MLD capacity treatment plant, 1.5 MLD capacity treatment plants, the 2 MLD at Hatta in Nanded region. Now, this is a prefabricated WTP of 1.5 MLD capacity. This WTP was taken on a hill rock. That's the highest in a Chiploon, Ratnagiri state, like 250 kilometers south of Mumbai. And it is that portable, like it can be stacked on a flatbed trailers and taken anywhere. As we can see, it is taken up the hill. That's how they are manufactured in a shop, transported on a trailer and taken up. So the minimum space required for prefabricated packaged WTPs from capacity of 0.5 MLD, that is minimum is 100 square meters of area, and for 3 MLD, that is 420 square meters of area. So silent features. Since the construction of small plants in RCC is cumbersome and time consuming, shortage of skilled labor in rural area further complicates the projects. Hence, prefabricated ready-to-erect plants is an attractive and alternate option for speedy and execution of water supply scheme. This system are modular system, hence quick and easy to deliver. All unit processes as per CPHO standards. It is very simple and small, robust and portable. Now these tanks are lined inside with a 5 mm FRP glass fiber reinforced polymer. So the water never gets in the contact with 6 mm. This requires the minimum space, shop manufactured, hence quality is very assured, cost-effective on-site treatment, and the quality of treated water is as per CPHO norms. It was found in like according to research of the treatment plants, it was found around like raw water turbidity was 25 to 50 NTU, and the pure water was less than 1 NTU. State-of-art anti-corrosive treatment for protection, which ensures long life of plants with glass fiber lining on the inside of the tank. Plug and play at site. List of organization plants are operation in various organizations, that is Peri-Urban Scheme, Maharashtra Jeevan Pradhikaran, Mukhyamantri Rural Drinking Water Program, Metropolitan Regional Development, Nagar Panchayat, Gram Panchayat, Jal Jeevan Mission, and so on. I want to thank AWW again for giving me this opportunity and allowing me to present at webinar on such an important topic. Thank you.
Thank you so much, Abhishek, for your presentation. It was very insightful, and we all agree that prefabricated water treatment plants do offer scalable, quick to deploy and cost-effective solutions, which is actually very ideal for addressing the unique challenges of water treatment in small and rural sites. So thank you so much for sharing your insightful presentation.
Thank you.
Yeah. We are going to present biological wastewater treatment technology based on advanced MBBR carriers for the treatment of wastewater generating from rural areas. The specific advantages of the technology is that it helps us to develop a robust process solution and which can perform under all conditions regardless of expert or skilled labor available at site. So, first of all, I would like to thank AWA for giving us this opportunity to present our technology and case study pertaining to the technology. We, as Biofilm Tech GmbH, are a Germany-based organization founded by Dr. Imre Passi, who has more than 40 years of experience working with Bayer AG for their Environmental Biotechnology Center. And as a part of our offering, we offer a complete process solution, starting from problem analysis to process startup and commissioning for various wastewater treatment requirements. And we do serve various industries such as chemicals, pharmaceuticals, petrochemicals, as well as pulp and paper industries, along with municipal wastewater treatment requirement for BOD/COD removal, as well as ammonia removal requirement. So during our journey in the wastewater treatment in early 80s, we had observed that biodegradation of any specific wastewater organic pollutant occur through a teamwork of microorganisms, and that microorganisms become part of an activated sludge flow. And we retain them in the activated sludge process for the required removal. However, there are certain important organisms which are very much essential for the biodegradation of a particular complex molecule or a particular ammonia containing substance. But due to their non-flocculating nature, they get washed out from the bioreactor. And despite they are getting developed in the reactor, but we are not able to retain them in the activated sludge flow, the performance of the activated sludge gets compromised, and we are not getting the desired results. So to retain these non-flocculating organisms, which are very much essential and important for the biodegradation of wastewater, there are various ways available. Like one of them is to immobilize them in a biofilm on a carrier surface and retain them within the activated sludge reactor. So there are various materials available for retaining to develop biofilm and to immobilize the carrier microorganisms on the particular carrier material. And that includes various material like plastic, sand glass, or maybe PP material, HDPE material. So to develop a carrier which provides ideal habitat for retaining microorganisms within any activated sludge process, our team at Biofilm Tech realized that an optimal carrier should have good absorbing capacity for the toxic pollutant binding, which also allows faster colonization and quick biofilm formation, so that the startup of the process can be shortened. It should have good high inner porosity and high surface area to allow protection of biofilm and to allow high space-time yield. It should have good, it should have fast wetting properties which allow homogeneous fluidization of the carrier material within the aeration tank, and it should have good water binding properties as well, so that it allows mass transport and good bioactivity, and it should be lightweight structure so that it reduces the fluidization energy consumption requirement. So considering these basic optimal properties of the an optimal carrier for biological wastewater treatment, our team at BioFilmTech has developed a technical grade, developed a carrier which is made of technical grade reticulated PU foam, and we are impregnating this reticulated PU foam with surface active pigments like activated carbon and some other additional pigment. So because of this combination of the high surface area, active PU foam and activated carbon, we Liverpool carrier has a very high amount of adsorbing surface, which allows rapid microbial colonization and biofilm formation. It allows also temporary adsorption of toxic and inhibitory substance, which can be then biodegraded by the microorganisms present on the biofilm, and it has surface area of around 13,500 meters square to 20,000 meters square per meter cube. It is having a slightly higher specific gravity of 1.02 to 1.04 compared to water. So it becomes part of the activated sludge bed very easily. And a dry weight basis, the weight of the carrier material is only 25 kilogram per meter cube of media, which reduces the energy consumption requirement for the fluidization of the carrier material. And a combination of these properties of a Liverpool carrier material offer a lot of advantages for the biological wastewater treatment, which reduces the process startup time. It helps us to increase the performance, or provide us better removal efficiency at higher volumetric loading rates, so that it reduces the footprint of the plant as well. Compared to conventional plastics, we require only 12 to 15% of volumetric filling requirement for the media, and it reduces the sludge production, and it also provides us a better sludge settling properties, improving the clarifier performance also. So compared to conventional plastic media, these are the specific benefits of Liverpool carriers. And over the past 20 years, we have applied the technology for the upgradation of existing sewage treatment plants, for the anaerobic aerobic treatment of high strength effluent, for the nitrification denitrification of high ammonia effluents as well, and as a MBBR IFAS process solution for the municipal wastewater treatment, both for the rural as well as urban areas. And now, conventionally, any free-floating media-based MBBR, free-floating media-based attached garage processes are offered in two process configurations. One is the MBBR process, which is moving bed bioreactor, and another is the IFAS process, which is integrated fixed film activated sludge process. In the moving bed bioreactor, it is a kind of one-through process where we assume that all the biodegradation will be happening on the attached growth media or the moving media present in the reactor, while there is no sludge recycle back in the system. While in the IFAS process, the MLSS, just like conventional activated sludge process, is recycled back to the system, and in the suspended growth, in the suspended phase, a significant amount of biomass is also present. So IFAS process is a kind of truly hybrid process which combines benefits of both activated sludge process as well as attached growth process, which has specific advantages, such as it has the same flow sheet as activated sludge process, and the operational and maintenance requirement for the processes are also same as activated sludge process. It can be configured with any activated sludge process model like AMILI, A2O, or plug flow type reactor, or step pit type of reactor. And at least compared to one standalone suspended growth process or standalone MBBR unit, it offers remarkable process stability, lower footprint, lower surge production, and lower energy requirement. So as in our process solutions, we are offering Liverpool carriers as a IFAS process solution, which is basically a single tank or single basin construction with 12 to 15% filling ratio of Liverpool carriers, and the system can be operated at a higher loading rate of 2.5 to 4 kg COD per meter cube tank volume, reducing the footprint of the biological wastewater treatment process a lot. And it can be operated at 2 to 3 ppm bulk PO concentration and can be applied with both fine bubble as well as coarse bubble diffuse aeration system without any problem due to the specific geometry of the Liverpool carriers. One of the specific application of Liverpool carriers based IFAS process is the upgradation of existing activities plus plants. Conventionally, existing activities plus plants upgradation for higher capacity for the ammonia removal requires to double the volume of the aeration tank, which requires new construction, a new land requirement as well. Perhaps it may require a new clarifier along with the new aeration tank as well, right? So it has a very high level of capex and opex involved in the upgradation project. But with the help of Liverpool carriers, we can add Liverpool carriers at a 12 to 15% filling ratio in the existing aeration tank, rearrange the diffuser grids, provide a retention screen at the outlet of the effluent weir, and the same aeration tank capacity can be double to take almost double flow rate and to achieve both BOD removal, COD removal, as well as ammonia removal as per the required new NGT norms or the new required stringent ammonia standards. And so that are the specific advantage that we don't require additional Beijing. We don't need to reconfigure the entire activities plus process. The overall process management philosophy for the upgrade process also remains same as conventional activities plus, and it can be utilized with any activated sludge process configuration. I would like to present a specific case study of 20,000 meter cube per day municipal wastewater treatment plant for a city in northern province of China. So during the year 2010, Ning'an city was constructing a 20,000 meter cube per day sewage treatment plant for their BOD removal requirement. However, all of a sudden their legislation changed and they required to design or they required to construct the plant with a COD less than 50 ppm and ammonia less than 5 ppm requirement. So due to very much space restriction as well as the availability of the additional budget for the civil construction, we offered them a solution to utilize the existing constructed activated sludge tank of 3,200 meter cube volume with addition of 15% Liverpool carriers or having a 480 meter cube of Liverpool carriers in the tank, and we helped them to upgrade the plant to 22,000 meter cube per day flow rate with a target to achieve COD less than 50 ppm and ammonia less than 5 ppm. So despite the startup during the October month, which is basically a winter month in northern provinces of China, the plant was able to commission within 3 to 4 weeks time for the COD removal, and it consistently achieved the required level of 50 ppm COD as per the Chinese government requirement. And despite not having much skilled labor to operate the plant, and to monitor the plant. The plant is consistently achieving the outlet requirements of COD less than 50 ppm, and nearly for more than 285 days, the COD is less than 39 ppm at the outlet of the secondary clarifier. We need to understand that this whole project is in a very harsh winter weather condition, whereby during the winter, the ambient temperature is plummeting as low as -15 to -20 degrees Celsius. For the ammonia removal also, nearly for 182 days, the outlet, the plant is achieving more than 80% ammonia and meeting the client's ammonia removal requirement of less than 5 ppm. And due to a very high amount of simultaneous nitrification, denitrification happening in our carriers, they are also able to achieve total nitrogen less than 15 ppm for their legislative requirement without having any pre-anoxic tank in the plant's process flow. So with the help of Liverpool technology, we have been able to help the province to achieve their compliance requirement with a robust process, which is delivering the required results consistently since last 15 years with the same carrier material. And the process stability is so remarkable that even normal unskilled laborers are being able to operate the plant without any problem, reducing clients' operational costs as well as total capital cost requirement a lot. Yeah, thank you very much.
Thank you so much, Dr. Amit. Amit, Amit for the presentation. I just wanted to check whether Dr. Aimer, you want to present or add anything else to this thing, or is it all done by Mr. Amit?
The most important things Amit has told already, and I would only repeat some things. Maybe I can tell us some interesting things. For example, we can use it also not for nitrification, but also to degrade spectral toxic materials. In sample in a chemical in a plant was, but they can be also in municipal wastewater. Chemical pyrazole is a heterocyclic compound, and it was non-degradable in two-step biotreatment plant. And then we made a suggested test to adapt the head start with so-called biostimulation. And we added in laboratory plant start % of carrier, added also nutrients and micronutrients, and also metabolites of the product. That means fractures, and started at lower dilution. Instead of 500, we started at 100 ppm, and I rated it with the same sludge from the plant. After 2 weeks, we had 50% degradation, then removed the water, new water, we concentrated with 240 milligrams of liter. After 10 days, we had a 70%. The third run was within at 400 milligram concentration, and within a week, we had a significant degradation. And this biomass and carrier we filled in a 2 cubic meter pilot plant, added more carrier and repeated it, and we came to the required removal. That was, we have started with 4 grams per liter cubic meter with the first run, and upgraded it within 6 weeks to 300 grams per cubic meter and day removal. And we thought it was possible, and that to transfer in the full-scale plant and such a way, they call it the bio-augmentation, we have also solved a problem. And the other application is also a municipal plant with H2S, that if you fill it in column and then adapt some bacteria, and from the incoming wastewater contains the air to 30 to 80 milligram per cubic meter H2S. Normally, some people did absorb it with activated carbon, which was generated and cost a lot of money. The bacteria, they don't take anything. Fill the column and colonize that with the bacteria, and with a blower, blow the H2S containing air through, and within 10 to 12 seconds retention time, they can oxidize and remove it by 99% efficiency. That means that is a very, very, how to say it, like a decathlon fighter. It's possible. Also, new active application field are fish farms where we remove ammonia, which is fish toxic, and it must be in this recycled fish farm that treated with the ammonia containing wastewater, what is coming from food, hydrolyzed food, go through mechanical separation, then to biofilter, and then within 15 to 30 minutes, all ammonia will be nitrified to the level lower than 0.5 milligram and recycled. And within a day, such water can be reused up to 20 times. So that was a short, only pictures what is possible, what else is possible. And yes, thank you. If there are questions, then we will have maybe interesting discussion about. I hope that other topics.
Thank you so much, Mr. Aimer and Amit. That was surely very insightful, because unlike conventional suspended growth systems, I think Liverpool's this fixed bed biocarrier system, IFES, surely I think helps achieve higher treatment efficiency with a smaller footprint and lower energy demand, which is really ideal for rural and resource limited sites. So thank you so much for consolidating and coming up with this system. Really appreciate. Now I think thanks to all the presenters.
So I think we should conclude now. So on behalf of Our India Association, I would like to thank everyone for attending our webinar on water treatment, sustainable solutions for small and rural sites. We are happy you took time to join us, and we hope you enjoyed this session. The special thanks to all our speakers and the moderator for sharing knowledge on the subject. And the recorded video of the webinar will be available on our website shortly. And also, if you're not a member of Our India Association and are interested to become one, please log on to our website www.our-india.org, or simply write into info@our-india.org. Thank you all again, and we hope to see you very soon at our event AIC 25. Thank you so much.
Thank you very much.